Okay, section 7.2. Two polygons are similar if all angles are congruent and all corresponding sides are proportional. So congruent is exactly the same shape and same size. Similar figures have the same shape. So this equilateral triangle is similar to this equilateral triangle. The ratio of the lengths of the sides is called the similarity ratio. The symbol for similar figures is just one squiggly. So congruent looks like this, and then similar looks like this. So example 1. Triangle, you read this as triangle ABC similar to triangle XYZ. So just like we had congruence, that angle A was congruent to angle X, it works the same way with similarity. So because we know all angles are congruent, we know that angle A is congruent to angle X. So A and X are the same. We know that B is congruent to Y. So B and Y are the same. And we know that C is congruent to Z. So these two are the same. We know that their sides are proportional. So AB is proportional to XY, as BC is proportional to YZ. So to complete each statement, angle B has to be congruent to angle Y, which we showed over here. The second one, if we know that BC is to YZ, we know that XZ is the same thing as AC. And then the last one is the measure of angle C has to be equal to the measure of angle Z. But we should go in actually, and this should be measure right here. We should go in and write what these angle measures are. So if I know that, because we can actually calculate these. If this is a triangle, and I know this is 42 and this is 78, this has to be 60. So these two have to be 60 degrees. And then angle B has to be the same thing as Y, so this has to be 78 degrees. Okay, down here, determine whether the polygons are similar. So remember, if they're similar, the angles are congruent, the corresponding angles are congruent, and the sides are proportional. So I'm going to, right away, if this is 120, this is a parallelogram, this has to be 60. This has to be 60, opposite angles are congruent, this is 120. I can fill out, this has to be 80, 80, 100, because this is a parallelogram too. So no, because the angles are not congruent. And then number 3, if triangle ABC is similar to YXZ, ABC, YXZ, find the value of X. So I can use a proportion. So I can do X is to 12, so if I do AC is to BC, well, AC matches up with YZ. So 40 is to XZ. 30. There's different ways that you can set this up too. I could have done 12 is to X as 30 is to 40 and got the same answer. You can do 40 is to X as 30 is to 12. You could do 12 is to 30 as X is to 40. There's a lot of different ways. So I'm going to cross multiply, use the cross product to get 30x equals 12 times 4 is 48, so add a 0. Divide both sides by 30. X equals, the zeros cancel out, 48 divided by 3 is 16. So the answer is 16. And then number 4, a painting is 24 inches wide by 36 long. Oops, I didn't even draw it right. The length of the postcard reduction is 6 inches. So the length is 6 inches. So this has to match up with here. How wide is the postcard? So W. So I'm going to set up a proportion. 36 is to 24 as 6 is to W. That's kind of the language that you use. 36 divided by 24 equals 6 divided by W is the same thing as 36 is to W, or 24 as 6 is to W. So I'm going to use the cross product. 6 times 24. So 144 equals 36W. And so you do 144 divided by 36. And W equals 4. And then I want to use inches. Make sure you answer in units. 4 inches. So again, there's a bunch of different ways I could have set up that proportion too. Okay, excuse me. So a video screen is 16 inches wide by 12 inches tall. What is the largest possible block of text that is 6 inches by 4 inches tall? So basically you have this 6 inches by 4 inch thing that you're going to try to enlarge and keep the same ratio. You still want to keep this ratio. So it's kind of like you have this large picture that you're trying to keep the ratio of. So what you do, oops, I need to get out of that. So what you do is you see how many 6's are in 16. So I want to do 16 divided by 6 is how many 6's are going to fit in there. So 16 divided by 6 is 2 2/3. Or maybe I'll keep it as 8/3. So I can fit something that's 2 2/3 all the way across. 2 2/3 times 6 is going to fit in here to be 16. Now I need to do, if I multiplied 6 by 2 2/3, I get 16. In order to keep the same proportion, in order to keep blowing up that 4 by 6, this is 16. What's going to happen with this 4? Well, I'm going to multiply this 4 by 2 2/3 too. So I do 4 times 8/3, and I get 32 on the top divided by 3. So it's 32/3, which is 10 2/3. So going across, I'm going to use up this entire block right here. So my dimensions are going to be 16 inches, but since 4 times 2 2/3 is 10 2/3, I'm not using up this whole part. So the new dimension is going to be 10 2/3 inches times 16 inches. So that's going to still keep your ratio of a 6 by 4. It's going to keep that the same. Okay, let's do another one. On a video screen that is 16 inches wide and 12 inches tall, so it's the same situation again. 16, 12. What is the largest possible image for a photograph that's 3 by 5? So I'm going to take my 5 and see how many fit into a 16. So I do 16 divided by 5. So 16 divided by 5 is 3.2. So I'm going to use up this whole part. This is going to be 3.2 times 5. So if I multiplied 5 times 3.2, I have to multiply 3 times 3.2. So 3 times 3.2, 3 times 3.2 is 9.6. So I'm using this whole 16 across, but only going up 9.6. That's the best way to use it. So 9.6 times 16 inches are the new dimensions. It's still going to keep that 3 by 5 ratio. Number 7, find the similarity ratio of the first figure to the second figure. So to do the similarity ratio, you take one side that matches up with the second side. So we know ABC, A matches up with P, B matches up with Q, and then R and C match up. So you can take one of the first, I'm going to take 14, because it says first figure to the second figure. So 14 divided by 20, or you could write it like this, 14 divided by 20, and then reduce it. So this is 7/10 or 7/10. Because it reads first figure to second figure, you put your first figure first. And then the second one, so we don't have any similarity statements like we did up here. So we're look at the angle markings. So this has one angle marking right here, and this has two angle markings. So I'm going to, the side of 15. So I'm going to find the other one that has one angle marking and two angle markings. So that means that DF corresponds to AB. So it's first figure to the second figure. So it's going to be 15 divided by 24, or you can write the ratio as 15 to 24, and then reduce. They both divide by 3, so it's 5 to 8, or 5/8.